Hello everyone. Today we will talk about dimensionless numbers like Reynolds number, Nusselt's number, Prandtl number. So first we will discuss about the Reynolds number. Actually, Reynolds number is defined as the ratio of inertia force to the viscous force. So we can say RE is equal to inertia force upon the viscous force. So here we can say inertia force is equal to rho v square rho v L square upon mu VL. So L to L cancelled, 1 V to V cancelled. Then we can say Reynolds number RE is equal to rho VL upon mu. Okay. Also we can say rho UL upon mu is equal to mu upon rho is equal to nu. Okay, so we can say Reynolds number is equal to RE is equal to rho VL upon mu or VL upon nu. Okay, in case of the pipe flow we will use the diameter, replacing this characteristics length L. So this L is characteristics length, and in case of the pipe we will use diameter D. So here we can place the dimensions of this formula. So rho is equal to kg per meter cube, this one, and V is equal to velocity meter per second into length is meter upon mu is equal to meter square kg upon meter second. So here dimensions of Reynolds number, this is equal to kg meter into meter second upon meter cube second kg. So this kg is cancelled by this kg, this meter and this meter is cancelled by this meter cube, and this s is cancelled by this. So this will be equal to 1 upon 1, means dimension is unit. It means this is the dimensionless. So here unit is dimension of Reynolds number is 1, means Reynolds number is dimensionless. So here there are three conditions. If Reynolds number is greater than 2000, less than 2000, then it will be laminar flow. If Reynolds number is less than 2000, then flow will be laminar means laminar flow. If Reynolds number is greater than 4000, then this will be turbulent flow. Okay, if RE is between 2000 and 4000, then it will be transient flow. Okay, so in between laminar and turbulent, the flow will be transient. So this is the Reynolds number, and this is the dimensionless number. So now we will discuss about the Nusselt's number, NU. So actually Nusselt's number is the ratio of convective heat transfer to the conductive heat transfer. So we can say Nusselt's number Nu is equal to HL upon KF, where Kf is the thermal conductivity of fluid, H is equal to heat transfer, heat transfer coefficient, coefficient of fluid, and L is the characteristics length. So for the illustration of fluid layers of thickness capital L and the temperature variation delta T, delta T, delta T, delta T is equal to T2 minus T1. So we can say, for illustration, let a fluid layer of thickness capital L and the temperature difference delta T, which is equal to T2 minus T1. So according to Newton's law, Newton's law Newton's law of cooling, we can say Q Q is equal to H A T2 minus T1, or we can say this is equal to H A delta T. Delta T is equal to T2 minus T1. Also we know that heat flux small q is equal to Q upon A is equal to, so this Q upon A will be equal to H delta T. Okay, so finally we can say Q is equal to H delta T. Q is equal to H delta T. So here this is suppose equation first. Now according to Fourier's law, we can write, so this is the Newton's law of cooling for the heat convection, and this is the Fourier's law of heat conduction. So we can say Q is equal to minus K A dt upon dx. Okay, or we can say Q upon this A is equal to minus K dt upon dx, and this is equal to small q. So we can say Q is equal to minus K delta T or dt upon dx. So here Q is equal to K dt upon dx, or we can say Q is equal to minus K dt upon L. So dx is actually the length equal to capital A. So this is equation second. So this is the for conduction, and this is equation for the convection. So we can say Nusselt's number Nu is equal to heat flow in convection upon heat flow in conduction. So this will be actually H delta T, this value, upon this value minus K delta T upon L. Hence, we can say Nusselt's number is equal to HL upon K. HL upon K. So now we will discuss about its dimensions. So here the dimensions of H, heat transfer coefficient H, is equal to watt per meter square Kelvin into M. So this is length. For length the unit will be in meter, and for the K this will be equal to W per meter Kelvin. So now we can say this value like watt meter square watt. So this watt and this mk will be in the numerator, and this meter will be in numerator, and here in denominator it will be W, this W, and this m square Kelvin. So we can cancel W to W, m to this m, and this m to this m, k to k. So unit is 1. So we can say this is dimension, this is dimensionless number, this is dimensionless number. Hence Nusselt's number is dimensionless number. If the Nusselt's number is 1, then we can say this is the pure conduction. Pure conduction. If Nu is greater than 1, then it will be effective convection. Effective convection. Okay, so now we will talk about Prandtl number. So Prandtl number is the ratio of kinematic viscosity to the thermal diffusibility. Okay, so we can say Prandtl number PR is equal to kinematic viscosity nu upon thermal diffusivity alpha, and here we can say this is equal to mu upon rho, and this will be K upon rho Cp. Okay, so we can say mu rho Cp upon mu rho Cp upon rho S. So here this rho will be cancelled. Okay, so sorry, this will be K. So this will be equal to mu Cp upon K. So finally we can say Prandtl number PR is equal to mu Cp upon K, where K is thermal conductivity. And now we will talk about the dimensions of this formula. So we can say mu is equivalent to Kg upon meter into joule into meter upon kg into joule. This cancelled, m to m is cancelled, so this m is cancelled, and kg to kg cancelled. This will be equal to 1. So here we can say the unit of Prandtl number is 1. That's why it is dimensionless number. Okay, so Prandtl number is also dimensionless number. So finally, we can say Prandtl number is the ratio of kinematic viscosity to the thermal diffusivity alpha. So PR is equal to nu upon alpha, nu is equal to mu upon rho, and alpha is equal to k upon rho Cp. By simplifying this equation, we will get mu Cp upon k, and now we will place the dimensions of these means mu, Cp and k here, and we will get the final unit 1. So it is indicating that this is the non-dimensional, is dimensionless number. So Prandtl number is dimensionless number. So we have discussed dimensionless numbers, Reynolds number, Prandtl number, and Nusselt's number in this video. And in the next video, we will talk about Biot number and Fourier number. So thanks for watching this video. All the best.